So have you all ever wondered how I built this? This was a flight computer which I had built a year ago, and in this video I am going to show you all how to build your own flight computer for your TVC rocket at home. So without any further ado, let's get started. So to design this PCB, we are going to use Easy EDA. You all can use any other software like Eagle, etc. But because it is easier on Easy EDA, we are going to use Easy EDA to design our PCB right now. So first of all, the first thing which we need to import is our Arduino Nano. So go to libraries, search for Arduino. Okay, Arduino Nano over there, press place. We need just one. So this is the Arduino Nano. You can see digital pins, analog pins, ground pins, V in pins, etc. This is the normal Arduino Nano schematic. So again, now the second most important thing, our MPU 6050. So just type MPU 6050, and in front of you all this C99 one, you'll have to select that one, press place and place it on the schematic, right? So you all have to just use the SDA pin, SCL pin, the VDD pin on your MPU 6050. It may be on mine it is VCC pin, but on your MPU 6050 it may be VDD or VCC, anything. It's the same thing, okay? And the ground pin obviously. So the next thing which we need to import is the servo motors. Let's go over here, servo. We need two of these, the X and Y axis ones. Okay, motor servo. Okay, this looks good. Let's import two of these. Let's name this one as, let's zoom in. Okay, X, and let's name this one as Y. Okay, we need two of these. So we have imported the Arduino Nano, the MPU 6050, the two servo motors. Now the next thing which we are going to do is regulate the voltage. So as you all know, we are using a LiPo battery which is 12 volts, and that is a lot to burn the Arduino Nano. So to regulate the voltage to a 5 volt DC voltage, we need a voltage regulator. And in this example, we are going to use a 7805 L7805 voltage regulator precisely. So we'll go into the libraries, type L7805. I'm typing with one hand, that's why it is a little bit slower. This one, L7805 ACP. Let's take this one, place it right over here. Okay, let's keep it a little bit organized. So now what we are going to do is just make the connections, and before that we need two capacitors, one 10 microfarads and one 1 microfarads. Let's go over here, type cap. Okay, it is in caps lock. Type capacitors, and we are going to use a normal capacitor like this. Okay, so let's rotate it. One is over here, one is over here, one is near the output, one is near the input. The left one is 10 microfarads and the right one is 1 microfarad. Okay, so once this is done, let's make the connections. We'll take a wire, connect this right over here, connect this right over here. Am I right? Yeah. Connect this, and then connect this, and then finally we are going to connect the ground. What have I selected? Ground to the ground. Okay, so the next thing which comes is the 12 volts. Let's rotate it. 12 volts input, and we get is the 5 volts. So we take a wire, connect it to the input of the voltage regulator. We take the output and connect it over here. This is NAT port obviously, if you don't know. And Okay, let's control set that. Let's rename this as your 12 volts and rename this as your 5 volts. So we are done with regulating the voltage. This module over here, right over here, let's group this. This module is your voltage regulator and filtering of the 12 volt voltage into a constant 5 volt voltage. So to give a small description on it, what it actually does is a voltage regulator is nothing but a Zener diode in backward bias. So any higher current you get, you always constantly give a 5 volt voltage. Over here the breakdown voltage is 5 volts because we are using a 7805, obviously that's why it is 5 volts. But if you all use any other voltage regulator, maybe any other 7810, if it exists, it will regulate it to 10 volts if it is higher than that. If it is lower than that, it may not, because it needs that breakdown voltage to work. Okay, so once this is done, we are done with voltage regulation. Now let's power up our Arduino Nano, MPU6050 and the servo motors. So to do this, we are just going to go over here, take a net port. Okay, it is selected as 5 volt already, so that's good. Connect it to V-in pin, same thing. Connect it to VDD pin of the MPU6050. Then take a ground port, connect it to ground and connect it to ground over here. Okay, so now our Arduino Nano is powered up and ready to go. So once this is done, let's connect the SCL and STA pin, which I had told you all are important. So the SCL and STA pin are important for the I2C communication protocol actually. Okay, so these are specified, like it depends from board to board, but for my board it is B, not D, A5 and A4 pins. Okay, it may change for your boards, you can check it out on Google. Let's connect the STA pin over here and SCL pin, and same thing, let's connect this A5 and A4. This shouldn't be 5 volts. Okay, this should be changed to A5 and this should be changed to A4. Same thing over here, A5, A5 and A4. So you all may not see it how it is connected, but actually they are connected because the names match. Okay, that is the use of netport. It helps us to like organize the circuit diagram. Okay, now our MPU6050 is connected, the Arduino Nano is connected, we have our voltage regulated. Now let's connect our servo motors. So to connect these servo motors, it is very easy. The plus means the 5 volts. Listen carefully. The plus means the 5 volts and not the 12 volts. If you all give 12 volts, I have made that mistake and I have burned one servo. So remember that. Okay, 5 volts over here. Let's name it as 5 volts. Okay, cannot edit over here. 5 volts. Then once again, we are going to give a 5 volt over here. Let's take a ground. Let's connect it to the negative terminal, ground to the negative terminal. Very easy, very easy. Then, okay, so the PWM signals, the PWM pin over here should be connected to the digital pin on your Arduino Nano, and that digital pin should be a PWM pin. What PWM means? PWM means pulse width modulation. So what pulse width modulation does is it helps us to control the speed of the servo also. Like it sends small pulses of data instead of like average data or something like that. Okay, so to identify the PWM pins on Arduino Nano, there is a little bit of a swivel type of a symbol next to them. I'll be dropping an image right over here, you all can see it. Okay, so let's connect a net port over here and over here too. and let's say this as D5, I think D5 and D9. I had connected it over there, D5 and D9. So these are just your preferences. So once this is done, okay, we have to connect it over here also, D9 and D5. D5, name it, never forget to name it, D5 and oops, D9, right? Okay, stay right there, D9. There you go. Your servo motors are connected and ready to go. So with this setup, you all can easily control your TBC rocket and do some ground testing right now with this setup. And really, if you want to launch a rocket and recover it properly, you all will need something called the pyro channels. The pyro channels are used so that the rocket can be recovered easily through parachutes. So you all can use that if you all are using some parachute recovery system or something like that. And as you all may know, I had introduced it once in my Arduino, like that this board, but later on I managed to burn it somehow and I don't have it right now. I had just clipped it off. So the next part of this video is the MOSFET and the pyro channel part. So stay tuned. So okay guys, now we are going to connect the pyro channels to our 12 volt battery, Arduino and MOSFET. So as I'm seeing MOSFET every time, you all may be thinking, what is a MOSFET? A MOSFET is nothing but you can say it as a some type of a transistor which switches on and off things. Okay, it's like a switch. So let's go in the libraries, type MOSFET. I think only one thing should appear. There you go. Let's place it. Let's place it right over here. Okay, deleted it somehow. Let's place it right over here. Zoom in. Okay, in making of the circuit, the main thing is organizing things. So we are going to move this set of things right over here because we are done with it. This set of thing right over here, I have moved the wrong thing. This set of thing right over here, and this set of thing is right over here. Okay, now what we need is the some resistances and a screw terminal. This is a screw terminal which I am showing you all right now. You all can use anything which has two terminals, but I personally used a screw terminal and I like it a lot because it can hold a lot of heat, voltage, current, etc. So just come over here and type screw terminal, and it should have two pins, right? So P2. So most probably you all should get one. Okay, something like this. Nice. Okay, let me look into the circuit a little bit. Okay, so we need to keep it over here. So the next thing which we need is a 470 ohm resistor and a 1 ohm resistor. So you all will think, why a 470 ohm resistor and why a 1 ohm resistor? A 1 ohm resistor I've just added it because for safety reason, but the 470 ohm resistor is a pull down resistor which is used to like filter any unnecessary signals coming from the Arduino so the pyro channel doesn't blow off by mistakenly. So you need a high resistance over there. So the 1 ohm resistance is connected from here, then it is connected through wires to this point, and then obviously you cannot fire the pyro channels with a 5 volt signal, right? You need to connect it to directly to the 12 volt battery, positive terminal. You cannot connect it anywhere else. You need to connect it to 12-volt battery itself. Otherwise the nichrome wire will not be heated enough to set up the explosion. So this is not 1K at all, because if it is 1K the current will never flow in it. So it is just 1 ohm. 1 ohm, not 10 ohm. Okay, 1 ohms. 1 ohms. I think that was ohm. 1 ohm. Okay. Then the next thing is we are taking a wire from here, extending it a little bit. Okay, leaving it there. We are taking a ground signal because we have not connected ground till yet. So we need to connect a ground signal over here. So this is connected. The next thing which we need is a 470 ohm pull down resistance. So 470 ohm resistance should be connected like here. So let's name it as 470. Y'all can use a little bit more or less. Then connect this right over here, and this thing should be connected. Okay, this thing should be connected to your digital pin on Arduino Nano, which will order the MOSFET to turn on or off through your normal code. So if you are thinking what normal code, then there is a video uploaded on the software of the code software of the TVC Rocket on my channel, which will be present in the DIY Rocket TVC Rocket playlist on my channel. So you can check it out over there, or it may be floating up over here also. Okay, so let's, okay, we don't need this wire. Let's remove this wire and just say it as, let's say D3. Okay, pyros we connected to D3. Okay, and we go to D3. Okay, and we connect it to D3 and we name this as D3. Hit enter. You're done with this. So finally we have completed the Arduino connection, the MPU6050 connection, the voltage regulation to 5 volts for our servos and Arduino Nano and MPU6050, the servo motor connections, the pyro connections, and we are done with the most important connections on our board. And some normal connections like buzzer connections, LED connections, you all can easily do that. Let me show one of that. So let's go over here, let's add a buzzer. Okay, buzzer, let's choose a normal buzzer. Okay, something like this. Let's take a round one. Okay, this one. Add a buzzer over here. This is a buzzer. One lead should be connected to the negative, the smaller lead should be connected to the ground, and the larger lead should be connected to a digital pin. You all get what I'm saying, right? This pin should be connected to, say, D4 is empty. Yeah, D4 is empty. So let's take it over here and connect it to a D4 and name it as D4. Okay, I've done something wrong. Okay, let's remove this and we will name this as D4. And with this we are done with the most important connections which you all need for a TVC Rocket. I'll be linking this document down in the description so you all can download it and just follow along looking at that schematic, or you all can just follow along with me with this video and make your own TVC Rocket flight computer like Veer, which I had made back in the day. So if you all want more of such videos, do let me know in the comment section, subscribe my channel, like this video, and this is Harsa1 signing out.
Yo, microphone check, make it a microphone check. Give it a microphone, I make it a microphone dead. Don't step to me, newbie, I could truly be moody. I could've played the fucking Grinch in the movies. I've been a part-time shadow cat, part-time. That is not a guy that I would ever wanna try to battle rap. Snap, crackle, pop, mind fried to a crisp, make it